Hello, I'm Ritika, and I'm going to briefly talk about this research that we did as part of a team under the mentorship of Dr. Shali Gao. The aim of the study was to address the issue of stable variable selection for with high dimensional genomic data, where often the predictors have strong correlations. We actually the So now the concern is that conventional penalty-based methods like lasso, group lasso, etc., they have been shown to perform poorly under such settings. And also, there has been recent work in this area, such as whitening lasso or W lasso and precision lasso, but not only do they not demonstrate consistently good performance across a variety of settings, they're also very complex. So we devised this method, which is called rPGBS, and it's short for repeatedly randomized pseudo group by level selection. So what is the method about? So the method can be summarized in three main steps. The first one is using the design matrix X and to obtain a pseudo group structure based on a randomly generated group number, which we say J. The next step is using a bi-level sparsity based regularized method to obtain the estimated betas. And then step 3 is repeatedly performing the first two steps based on the randomly generated group number, and then summarizing the variable selection results based on those repeated sort of runs of the first two steps. Now, some more details for clustering the variables into groups. We use the PAM function, which is available in the cluster package in R. And for bi-level selection, we used existing methods, namely composite MCP or CMCP and group exponential lasso or GEL. And also the process of each process of randomized group assignment and bi-level selection is termed as an epoch, and we run M epochs in order to summarize our results and to estimate the probability of a variable being chosen as active. This is what the algorithm looks like. Now, for our simulation studies, it was divided into two categories. The first one was when the response is continuous, and the second is when the response is binary. So when the response was continuous, our settings were N and P were set as 200 and 500 respectively, and beta for the active variables was randomly set to be 1 or -1. There were 10 active variables, and we used different types of correlation settings: clockwise correlation, group-wise, par decay, and then we used a setting which had strong correlation and also linear dependence. We compared our method, rPGBS, with a variety of methods: lasso, MCP, elastic net, group lasso, and the more recent methods like whitening lasso and precision lasso as well. And how we compared the variable selection results were based on these quantities: total accuracy, total positive rate, total true negative rate, sensitivity, specificity, and total number of variables selected. And in all our simulation studies, we found that for the continuous response, our rPGBS demonstrated about 99% of percent total accuracy across all settings. For the binary response, we used we set N to 500 and P to 200, and we used all the methods previously used in the continuous response data, but other barring whitening lasso, as that package is only designed for linear regression model. And also we used the blockwise correlation structure. Now, here are the ROC curves of rPGBS across all the simulation settings that we tried. So we tried 6 simulation settings, and it does best for blockwise linear and blockwise logistic, but it's consistently pretty well performing across the other settings as well. Now I'm going to talk about some of the real data analysis. For real data analysis, we picked 2 data sets. One of them was the breast cancer transcriptomic data, which had a continuous response, and the other was a leukemia data set, which had a binary response. And for the breast cancer data set, actually for both of them, they selected fewer variables compared to other methods. And also it had the lowest prediction error for the breast cancer data set and the lowest misspecification error for the logist data set, or the for the logistic regression, which was done using the leukemia data set. So to conclude, we can say that rPGBS demonstrated stability and consistency in in the selection of variables, and also compared with much recent work in the area, which is the whitening loss and precision loss. So it's it's computationally much more simple, and thus it's faster. And so it would be good to utilize this method and to explore more into this method and see how it can be used in the most optimal manner. Thank you so much for watching my presentation.